Hello, everyone, and welcome to the Canadian Electricity Association's Conversation webinar series. My name is Dave McKendry. I'm Senior Fellow here at the CEA, and I'm pleased to be your host for today's webinar. CEA has been working with our corporate webinars to develop the Conversation series, which focuses on solutions to current and future challenges faced by our industry. Today, Aggreko Canada will be presenting Preparing Transmission and Distribution Companies for Unplanned Outages. Our presenters include Wajid Ali, Utility Sector Transmission and Distribution Specialist, Eastern Canada, Dave Bell, Utility Section Manager, and Aaron Cook, Engineering Manager. More than ever, transmission and distribution utilities across North America are working to find innovative tools to deliver power reliably, enhance customer satisfaction, and retain existing customers. However, there's a need to bring more flexibility into the existing pool of resources due to system complexities such as aging infrastructure, remote communities, and radial feeders in the system. Aggreko will be presenting a methodology to provide transmission and distribution utilities an extra lever that can immediately reduce customer minutes of interruption and improved estimated time of restoration, or ETR. This webinar will be of interest to distribution grid engineers and operators, along with others interested in managing unplanned outages. Before we get started, please feel free to ask any questions in the area of your webinar screen as they come to mind, and we'll get to those questions at the end of the webinar. And we will be sending out a copy of this presentation, a recording of all the audio, video, and slides at the conclusion of the webinar that will go to those that registered in particular. And we'll also providing a post-webinar survey. And we certainly do appreciate your feedback. In fact, if you have any questions or suggestions for topics that you would be interested in hearing about as part of the conversation series, please let us know. Dave, I'll now call you to the platform, and we'll turn the webinar over to you.
Thank you, Dave, for the nice and kind introduction. As we're discussing, we'll be talking today about preparing T&D companies for planned outages. But first, I'd like to kind of start by introducing myself and who we are. And I'm excited to be here for this opportunity. But for those of you that don't know us, Aggreko is a worldwide organization that focuses on temporary utility projects. We're in almost every continent in the world. We have thousands and thousands of employees. And personally, I'm from Ottawa, but I now reside in Calgary. As David said, I also have Wajid here, and Wajid's in Toronto himself, and Aaron Cook, who's our engineering manager, who's actually out of Louisiana. So I know a lot of the utilities know us, and they've done projects with us before in the past. But for those of you that don't, Aggreko helps T&D companies improve their grid resiliency and capital productivity while improving their return on equity and their reliability metrics at the same time. So before I get started with the topic here today, I thought I'd bring this up into the attention. I'd like to take a few minutes to acknowledge the utilities in the southern United States and their mutual assistance partners, many of them Canadian, that have been working to restore the power to the people of Louisiana and Texas. This has been a huge undertaking from the local utilities with their mutual assistance partners. At one time, there was almost 250,000 people without power. And as last night, there's less than 10,000. It's been a great struggle for them, and they've been overcoming that struggle every day. So there's still a lot of work to be done, and the utility teams are working hard to ensure that that gets done as possible. But always let's take time to thank a line worker and a utility worker for their ongoing support. And for those of us in Eastern Canada today, our thoughts are with you, and let's hope Teddy doesn't have the same sort of impact as Laura did to the people of Louisiana. So for the topic at hand, as the utility becomes more efficient, our customers become more and more reliant with our services. And with that reliance on the clean electricity, there's stronger focus on how to serve our customers. This presentation will outline one of the ways that we're helping multiple utilities across North America to improve the reliability of their system. This presentation will focus on how we support you through your customers during unplanned outages while improving reliability metrics like Sadie, Katie, in improving time of restoration, and improving your customer satisfaction. The title of this presentation is Preparing for Unplanned Events. This sounds a little oxymoronic, and I understand that. And sometimes unplanned events, well, they're hard to plan for. And we felt that way for years too. And for years, what we did is we actually supported the utilities by taking reactive calls to emergent issues. As we started working through it and working with our more sophisticated clients, we started to understand that we had to find new ways to improve. And the best ways we found is to be actually more like the utility. Although the utility can't predict exactly when and where an outage is going to take place, but they're prepared for the certainty that it will take place. These happen on a continual basis, and how do we support it properly? So we started looking at things that we could predict and things that we could affect change on. And when we started looking at that, we started looking at outages that are longer than 6 hours. So in a duration of greater than 6 hours in territories where we can serve them quickly, right? Or strategically place or plan on equipment and resources being close to the areas that maybe have some trouble areas. But most importantly, the trends. Is there any order into the chaos? Is there anything that we're noticing on a regular basis that'll help us prepare and plan better for these outages? So here's a Canadian utility that we're currently working on and looking at some data and trying to analyze how we can support them right now. So we've changed some names of the territories, and we made the data relational for anonymity purposes, but it holds true to what we're trying to talk to today. So the company provided us with about 3 years worth of data. We pulled all the outages greater than 6 hours, and we put them into buckets of servable territories. Territories where we can re-energize them with proper planning in 3 hours or less. So what we found is we can impact real change in their business. There are definite trends, right? And we also found that we didn't need to solve every outage to make an impact. We just needed to focus on the ones and the places where we could make an impact. And we could make an impact on a large portion of their issues with one standard offering. Now, that standard offering does change utility to utility or region to region, depending upon the idiosyncrasies of each utility. But what we're finding is those trends are consistent, right? That every utility within North America has some sort of trend. So if we look at this data here, what we'll notice is that even though if the light gray box is year 1 and the dark gray box is year 2, the averages are coming out fairly similar. So you can see the trends throughout these outage areas in these spaces. So and you'll see that obviously the CMI is actually very relational to the number of outages that are occurring as well. So in an average year, when we looked at it, most extended outages, 23% would account for about 23% of the annual CMI for anything that was over or greater than 6 hours. And they could have been addressed by one particular pieces of equipment, right? So a particular offering. And this holds true not just for this utility, but we're seeing it everywhere else as well. And so what happens is basically one simple solution could account for 23% of the total CMI for that utility. And you might be wondering why that's important. And the reason why it's important is because it speeds up deployment time. What it does is it allows us to set up properly, and this could be deployed, it could be multiple of the same pieces of equipment in different territories or multiple pieces of the same equipment in the same territory. But either way, it helps speed up that deployment time. And the other thing is we could also prep all the needed ancillaries around that equipment. Anybody that's built a deck in their own backyard or done something like that knows that nothing is more frustrating when you're going to finish your deck and realize you're out of screws and you have to run back to Lowe's in order to pick up the screws. The other thing it does is it provides a continuity of service. It helps keep everybody safe, because in the long term, as they recognize that piece of equipment that's coming up, they know how to react and respond to it. And it helps with the safe work programs for the utility and for Aggreko. And it becomes easier and easier to deploy. So over time, we just become better at deploying. When we typically start a new relationship with the utility, they often ask us, how quickly can we be there? What is your ETA in order to get to us, in order to support us properly? But what we found out is they're probably more concerned with how quickly they can get their customers online. And what we have to do is make sure that we can get them restored as fast as possible. So when we looked at this particular utility, what we've done is we took back and said, if the intervention process takes 3 hours for us to deploy our equipment, on this particular utility, we found that we could actually speed up the time of restoration by about 13 hours, because their average time of outage is 16 hours. And this would also impact CMI quite a bit and dramatically. So if you look at the intervention time of 3 hours, that would equate to, on an average, about 700 CMI. But the total outage would have been 3,700 CMI. So greatly improving the customer minutes of interruption for any given utility in the market. Now there's some detail that has to be worked out. And obviously it's going to be different from territory to territory, but for all in all, the trend remains true. The other thing we noticed is through analysis of this particular utility, right, with that one simple offering deployed multiple times, it can affect change on about 22% of the CMI for this utility. So now that, of course, excludes the CMI that is less than 6 hours, right? And there's different territories have different challenges. For example, it could be a highly congested area, difficult to get there. Another trend that we're noticing on a quite regular basis is that these outages seem to not happen 9 to 5 Monday to Friday, but 6 o'clock on a Thursday or Friday afternoon before a long weekend, as people are trying to commute out of town and get back from work. So how do we deal with that? Or it could be a large rural area. So vegetation could be part of that issue. It could be birds, it could be nestings, it could be all kinds of challenges that they have. And rural areas have a different challenge, right? But when we prepare for them, we can figure out ways that we can deal with them better. But the one thing we did come across, and the things where we are being successful, is we noticed that success didn't require us to be perfect, just be prepared. So if you took a look at this utility here, the total addressable outages are 380, right? And with the total CMI addressable per outage is around 3,000, right? The total avoidable CMI for this territory would be 1.1 million, and the total annual CMI would be 4.2 million. So you can see that would make a dramatic impact year over year in the improvements of their CMI, their Sadie, or their metrics that they're trying to do. And of course, most importantly, is giving them the ability to serve their customers the way they want to serve them. The other thing we always look at, is there another trend in maybe, could it be seasonal? Could it be territorial? And we already talked about territories as well, but the other thing is that it could be seasonal. In this particular utility, we don't see a seasonality to it in their North Region territory. There's a little bit of a dip in the summer, but in the fall and the spring being a little bit more, having a little more outages. But the reality is that if it is seasonal, we can also address those as well. And so if you have a territory that, for example, is over the spring and the fall, you're having more outages that you want us to help mitigate, maybe that we can address that over those quarters instead of the whole year. So we're open to those ideas. So you're probably wondering, how does being prepared and what does being prepared look like? Well, typically how we like to address this is a lot of times with the utility, they come to us and ask us questions like, what's your ETA? How fast can you respond? Where are you located? What are you doing and how can we help you, right? Or how can you help us? But when we sit back and we have a real discussion with these utilities, we understand that it's probably best to take a step back, right? Breathe with each other and see what the analytics are telling us. So in particular, the utilities data that we're showing here today, and again, we sat down with that utility and we basically asked them, can you reveal to us what that utility, that data looks like? When we took the data, we did the analytics with them, and it reveals a lot of things with fresh eyes. I think the other thing that's been important here on the analytics side is that it's the fresh eyes and the difference between us looking at it and how you guys are looking at it from the utility perspective. And then what we do is we sit down and we agree on what we can solve for. Again, I'm going to say this again and again, but we don't have to be perfect. We just have to be prepared. And so where's the real difference, and where can we make a change together? What's the change that we do want to make? Whether that's a CMI target or a Sadie target that we're trying to achieve or get better year over year. And then we consult. So what we do is we like to get into the field with the area's team. So if there's a specific area or zone, or there's specific people that are in charge of those areas or zones, what we like to do is get together with them and talk about specific challenges that might be specific to their area. And then we talk to the groups and we assure that we're trying to win as one, meaning we'll pull in people like the HSC teams, the lines, the stations, grid operations, protections and controls, making sure we're all aligned in order to make sure that that standard work process gets delivered properly. And we do things like create communication protocols. How do we call this in? So Dave, when this issue happens, how do we call in? What do we do? How does that work? And then we also have our own internal processes as well as the utility has their own internal processes in order to communicate this trouble issue that they're trying to resolve. And then we'll sit down with Aaron's team and the design and engineering team, and we'll get those design and engineer the right package for that right solution. And then we'll consult back with you with the utilities to discuss if this seems like a fair way to handle and deal with this. And then at that time, we need to train. So train both teams. It could be the utility team and the Aggreko team. There might be specifics that you guys need us to do, and there might be things that we're going to need from you. And so what we do is we sit down, we get familiar with one another, understand what our work processes are going to be and what those workflow processes are going to happen, and then execute. So again, we don't need to be perfect, just prepared. And in this case, prepared is safe. So as long as we can do this safely, right, and we can make sure and we can ensure that that can be done safely, what we'll do is we'll work on those execution plans, and then we'll review those, and we'll measure and review. So we'll go back to what we were talking about when we were saying we're going to agree on what we're solving for. And then we'll go back and measure what we've been doing. And are we actually getting to where we want to be? Are we seeing a change, right? Is there things that we can improve on? What do we need to do? And then we'll take those analytics and we'll go back to it and we'll start all over again and hopefully re-engage that for the next year, the next season, or whatever problem we're trying to solve at that given time. So what does success look like? Here's an example where the utility had a particular area that they could really improve their CMI. Although the territory was small, it was an extremely populated area with difficult infrastructure. In the consultation process, it was determined that we could strategically place resources, the equipment and people to meet the time of restoration. The utility put onto us a 2 to 3 hour time of restoration. So we estimated that we helped this utility save 4.5 million CMI in one small territory in 2019. We deployed 58 different installations, mostly on the secondary side of distribution, so a low voltage side. And we got the estimated time of restoration, or the time of restoration, to anywhere between 2 to 3 hours on most deployments. Right? But in order to do that, we needed to work on a strategic logistics plan. This is an old part of North America, and it's extremely densely populated, small streets, difficult areas to access. So we needed to be smart with that. And so what we did is we strategically placed resources in an area that can easily deploy into the area that they needed to do. Again, this is probably where we learned more about ETR, or time of restoration, versus ETA. And so the utility was asking us, how can we speed this up? So we worked with them and created special connectors, whether it's going into the high line or into the underground residential distribution system. And so we set up special connection points that sped up that timeline. Also, I think if you ask the linemen, I think, and the people that were on the ground, they'd feel safer in this type of application because they got to use it more and more. And then we created a strategic communication protocol. So what that means, when they call in at these times, what needs to happen, how quickly can you get there, and then that protocol. And if we were running into challenges, for example, sometimes weather, we would need to communicate that right away. They had to report that back to their Public Utility Commission and report that back to their team and the grid operations team on that time of restoration. So honesty was of the utmost importance. Here's another example where the utility thought it would be better to support their customers, but this time they wanted to do it more from the distribution primary side. And so most of their territory on the distribution side was a 12.5 kV system. They were looking for a system that could be safely deployed quickly. So through analytics consultation process, it was determined that this particular setup that you see in this image here would meet all their demands with regards to the protection and controls, create an easy and repeatable standard work process, and be safe for the community employees. So simple, easy trailer, one type of deployment goes out and can set up and energize 300 customers in any given time really quickly in less than that 3-hour window. So in this particular case, there's been hundreds and hundreds of installations over the last 3 years and millions of CMIs curtailed. So this has been in practice for over 3 years now, and it's been proven to be very helpful for the utility in California. Although this is not the topic of conversation here today, we get asked a lot if we can support major events. And the answer is yes. It's a little hard to prepare for them. Although as a business, we're constantly monitoring weather patterns and weather trends and how we can support and strategically placing equipment where it needs to be placed. But those events, when they happen, I guess the best way we can respond is by being always prepared for you in the background. And so recently, just to give you an idea, we're supporting Hurricane Laura. We have over 50 megawatts of installation to the utilities. And that could be anything from a 60 kilowatt to operate a hotel or a small hotel or even a pharmacy for that matter. And everything up to 15 megawatts that we're running right now currently for substations due to decimated transmission systems. Another good example of this is in California currently right now, where we're supporting, we have over 100 and some megawatts to support the public safety power shutoff program and helping that utility make sure that they have a safe community through these wildfire and these other challenging times and events. In summation, I think having the right plan in place with the right partner can help the utilities make intelligent business decisions in order to improve their stringent targets. And just by taking the time to do some analysis, come to some sort of agreement and consult with one another, we can design and train and execute a project really quickly. And then if we review, we continually get better year over year and time over time with one another. Again, the target doesn't have to be perfect, but the target does have to be prepared. And that's really what we're shooting for here. And so what we found is with those utilities that we're working for, they have an improved customer satisfaction and reliability and an improved time of restoration. I thank you for your time. I understand, Dave, that we're going to be taking some questions from the group.
Yeah, that's great, David. And if you'd care, please feel free to turn on your camera, and also invite Waj and Aaron to do the same if you'd like to come on screen with me as well. So thank you very much
was
for.
on camera that whole time?
No, you were. It was. You were great. It was great. Yeah.
I put a jacket on and everything for this. Right?
Now we get to see the magic behind the voice. It's all good. It's all good. No, a very interesting presentation. Boy, oh boy, this is a topical conversation these days, especially with the changing weather patterns that are going on. Aaron, we know that you're currently down in the United States. You're doing some work with that's very important work along with these utilities that Dave was talking about. Waj, I know you've got a lot of experience in this area as well. Would invite our viewers to chime in with your questions as they come to mind. Just simply go to your the location on your web screen and type away, and we'll get to them. We do have some questions in already, and Dave, you'd mentioned and showed some pictures of the installations that you've done, and you showed some significant trailers with equipment on it. What specifically are in these boxes? Is it generation gear? Is it substations, interim solutions? What's in the magic boxes that you're trailering around?
Yeah, absolutely. So Aaron can speak more intelligently to this because he's the designer of all this. But really what it is exactly that. So if you think of a normal installation at a substation type level, you'll have needed some sort of way to create the electrons, and that would be a generator. So we have natural gas generators, we have diesel generators in order to support that. And when I say natural gas, it can also be propane gas, even on a smaller application as well. And then we'll need some sort of way to get to distribution type level, right? And so it could be a low voltage installation, so maybe nothing's required. They'll typically generate at 480 volt or lower voltage, and then we'll have to have some way to step up that the power to a usable voltage for the utility. So we have transformers, all that equipment that needs to do it. And then for all your protection and controls people on the call, right, we have a switchgear protective devices, whether that's 15,000, 25,000, or 35,000 volt switchgear and equipment like that in order to isolate the equipment, protect all the lines and the customers that it's serving. And then as well, we have a high level of breakers and the breakers at a certain voltage. So in some instances, we can actually tie in and use the breakers that are actually at the utility, and we can actually use it at the substation. In other cases, that's a discussion between Aaron's team and the utilities team and what's best to serve. But in some cases, we prefer to go just in the high line just because maybe it's easier. And so we're going to use our breakers and our relays. And we have a variance of those. I think, Aaron, our most common is SEL 351 relay. Is that fair to say it's most common?
Well, we've actually, over the last year, we've been standardizing on the 751 feeder relays. But I can expand a little bit about the picture that you showed with the white boxes. So
yeah, please, Aaron. That would be interesting.
Over on the left-hand side, the first box is an engine generator set, diesel, 500 kilowatt prime mover. Are you going to go back to that screen? Okay, there we go. 500 kilowatt prime mover, 750 kVA, three-phase alternator. Over in the and that produces electricity at 480 volts, three-phase, 60 hertz. Over in the center, we've got an oil-filled transformer, 750 kVA. The vectors are Y-grounded, and it is 12.47 kV, 480 volts. And then the white boxes over to the right of it, we've got several switching components. Primarily, the main thing to focus on is the 15 kV vacuum breaker, and it's draw-out style, industrial style breaker. We've got some PTs, some CTs, and some protective relaying components in there. The one in this particular box is an SEL 300G. It's a generator management relay. One of the main differences between that relay and some of the feeder relays that we use, such as the 351 and 751 relays, is this relay has voltage restrained overcurrent, which is a particularly good thing to have whenever you have a very small source in relation to what you would normally have. And what I'm talking about is short circuit power. So when you have a grid connected source, you will have very large amounts, copious amounts of short circuit amps that you could then use to trip breakers, trip reclosers, trip fuses. But when we have a very small, or aka weak source, is what a lot of utility engineers would call this, when a fault occurs, whether it's phase to phase, three-phase, phase to ground, the voltage is going to decay, and voltage restraint over current allows us to detect short circuits, even if the short circuit amps is limited by the source. And the nifty thing, one of the other nifty things on the back of this trailer, way in the back over on the right hand side, is a junction box, and inside that junction box is a set of load break junctions. So our utility company, our utility customer can use a set of his cables with load break elbows and plug in. So we're not bolting on connections, we're plugging in just like you would have in any kind of underground or pad mount switchgear. So it's a pretty nice setup. We just pull in, start the generator, go through our safety checks, and we're up and running, like Dave says, just within a couple of hours.
Wow, that's amazing. As you describe that, in my mind, I've got basically what you're describing is a utility in a box. It's instant portability, and and you're there. Waj, just a question for you in terms of how many of these mobile devices does Aggreko have, like across Canada or North America? There must, numbers.
Well, we have tons and tons of these devices, and they're scattered all across North America. So whenever, as we sit together with utility companies and we make a plan, we strategically locate them and situate them closely to them so that they can be mobilized within 2 to 3 hours. But to your point, they are located and scattered all across North America. And we have
Wow,
tons
so
of those boxes.
I take it as you would work with customers in terms of some pre-planning, they would probably want to know if we're going to pre-plan that these types of units are somewhere within quick recall if I needed them in my utility. Would that be a fair assumption?
Yes, some of them are like let's say if somebody's from Ontario, we have offices in Ontario, depots in Sarnia and Brampton, which strategically can target some of the location closer to Brampton and Sarnia. However, as I'm just repeating it, if there's a plan, we can even get it more closer to northern parts of Ontario, or if we have offices in Edmonton, we have offices in Fort McMurray, we have offices in where else do we have offices in the Western Canada, Dave?
Calgary and Vancouver.
Yeah, Calgary, Vancouver. So these are prime offices where we have all these equipments parked and stored, and then we can move it whenever needed.
Wow.
I think, just to add on that, Dave, if you don't mind, the other thing that we're doing is we partner with them and we take a look at, like, the analytics are so very important. And so when we take a look at the challenges that they're seeing, and it sounds crazy, but I mean, we have an office literally, if it was Sunday afternoon, it would take you an hour to get there to serve them, right?
Mm-hmm.
Friday at 3 o'clock, it would take you 8 hours to get there. So we have to strategically talk about those challenges and how do we overcome them, and that's the real important part.
Right. Now, obviously, if you get into some wild situation where the wires have been disrupted, we saw some of the towers are down and whatnot. It becomes a little trickier to like this utility in a box can't solve all those problems, because if wires are just down, they need to get fixed. But it sounds to me like when there's some major infrastructure that's been significantly damaged, you can do a plug and play pretty much to help get things going fairly quickly. Is that right?
Yeah, so what we do is work with Aaron's team, and so obviously the utility's gonna have to decide that, right? So Laura is a really good example of that currently right now, what's happened. They're like, we need a 300 kW generator over here, and we go there and there's no roof on the building, and the generator's not gonna help them, right? So it's the same thing if you take a look at it from the distribution system. So right now we're working with partnering with them. We're going to be installing later on this week. It's I think it's about 15 megawatts we're going to be putting at a plant. But the reason why they're stalling, we're getting placed and we're getting put in place, but they have to build the D lines back up. The transmission will be out for another 3 to 6 weeks, right? So while they're building the D lines, we're setting up our stuff so we can energize them, at least get the customers back to normal or some sort of normalcy, help them get dried out and everything else that's caused by a hurricane. But you're right, you have to take an assessment level at that point.
Yeah, and your technology works both in the transmission area and in distribution, is that right?
Yes. So what we typically do is we support from the distribution side. So we're more of a customer supporting side. So a lot of the work that we do, the transmission is out, for example, but we're helping on the distribution side because the customers are there, and there may be some point of use there might be some point of use where it's a major customer. So for example, up by Cambridge, there was a Aggreko steel plant that was out, and we were able to support Aggreko. The transmission line was out, but we helped them specifically on Aggreko steel property.
Great. Again, what's the largest size that you can snap into place in this utility in a box mode?
Currently, right now, I don't know what country it's in, but we're gonna do 100 megawatts. Is it Bahrain? Right?
Wow.
I can't. So
wow.
Yeah, and we're very fortunate, especially in Canada, where we have such good clean energy and we're using electricity. I mean, some other places we're just supporting them just to get energy, right? I mean, we take that for granted a little bit, maybe in Canada. You know, I took my daughter's light bulbs out of her room the other day because she left her light on all day. So if she didn't respect it, she can't have it, right? But the idea of that is we can support at very high levels, and sometimes. For example, we're working on a project right now in the Northeast where it's going to deploy early in March. They're about 60 megawatts, but the best way to support them is in multiple pockets, right?
Right. So it almost sounds like a little bit of you guys offer a bit of an insurance program, for lack of a better word, that if a customer has a relationship with you that in dire need, you could swing in with this type of a solution and certainly dramatically reduce the estimated time of restoration, as an example. Sounds like.
That's correct. So the equipment on the trailer and the photo that you're showing right now, that's been on hire all summer. And when the utility company needs it, they know where it is. They know how long it's going to take to get to their site because they're in control of it. And it's instant 12 kV in a box.
It's that's a great description. Hey, look, I appreciated learning about your cycle in terms of, it starts with data. You do your data collection and the analysis, whether it's year over year or seasonal, and then you do your agreement on what you're solving for in the bidirectional consultation. Design and engineer, train, execute, and measure and review. Just a question in terms of the data side of the equation. I know that in some cases from a distribution-only utility, sometimes the time that the power is out excludes loss of supply, or it accounts for loss of supply because they are not controlling that. The data that you were just showing earlier, David, was that including loss of supply, or how did that data turn out?
Yeah, so you're right. So that data does include loss of supply on that side because that loss of supply. Anyway, yeah. So the customer happens to have transmission and distribution. So.
Yeah. Okay. So that varies customer to customer. Next question that's come in. How can this proactive approach with emergency preparedness improve customer satisfaction and improve Sadie?
Yes. So Sadie, it's kind of. It's just kind of in there, isn't it? Right. And so obviously you have major event delays, but when it's not a major event delay, that Sadie number, once the clock's ticking, it's integral to get up and running. So we can't do anything about the safety event, right? The frequency of that. The event already happened, it occurred, right? But if we go back to the slide where we looked at it, it was like we can intervene within 3 hours, and it's a 16-hour average outage, right? So that comprised time. The other thing that I'm dealing with a lot, the utilities are asking us, we have these customers and they're not necessarily the Sadies impacted, but they're experiencing long duration outages or multiple duration outages, and there might only be a few hundred customers on the other side of that. So it doesn't impact the total Sadie, but their customer satisfaction is what they're really caring about. How do we help them? In fact, we just did a project in the middle of a remote area recently, Wedge, and I think there was 7 customers, but the utility felt it incumbent upon them to serve those customers for a short period of time in order to support them. And we're seeing that more and more.
And the reason there was loss of supply, just to your point, David, it is they did not have a supply, so they were utilizing Aggreko for almost 5 days to supply those 7 customers. That's right. Yeah.
And it was a generating company that actually lost the supply.
Yeah, it's turned anymore that no customer is statistically insignificant anymore. In other words, everybody's important because they can go to social media and they can tell a lot of people. So utilities are very attuned to ensuring that everybody's on board. Just a reminder to our viewers, if you've got a question, in addition to the ones that are coming in, please feel free to tap them into your webinar screen, and we'll look to get to that. Next one that has come in. So what does Aggreko need from utility to establish an improvement plan? Like you were talking about the consultation and whatnot. So what stuff do they need? I don't know, Aaron, would that be something that you'd address, or is that David?
I think it's both, actually, right? So from a technical perspective, Aaron can talk about that and what that would look like. I'm going to just start it off by saying there has to be a level of trust. We understand, actually, one of my colleagues might be even listening right now. He always says, it's like, we have milk for the dairy. we're the temporary utility for the grid, right? It's a big claim to make, right? So there has to be some level of trust. In Aaron's team, that's what they're there for, is to prove the competency, right? So Wadge is just the good looks of the company, but Aaron is definitely the brains, right? So I'll let Aaron speak to
the confidence, Wadge.
Absolutely, I like it.
We'll let Aaron speak to it more, but.
Yeah, so as far as the plan goes, if we look at different areas, and we look at load characteristics of, let's say, 50 different areas, and maybe 40 of those areas are going to have loads of, let's say, less than 200 kilowatts, then as far as planning goes, then we know that we can probably use a 300 kilowatts, maybe even a 500 kilowatts trailer mounted instant 12 kV or instant 4160 or 25 kV in a box to feed the vast majority of those problem areas, or those areas that have a higher likelihood of losing power. But from an individual location or individual standpoint, we need to know per phase amps, per phase kW, power factor, connection points. We need to know. We need to know, we need to find out if we can physically fit all the equipment into a particular site. And there's a list of probably 20 different questions we need to address when we're trying to figure out what we can do at each particular site. But voltage obviously is very important. One of the things that you'll find is that in many cases, some of our utility customers might refer to voltage as phase to ground. So somebody might say 14.4 kV. Well, to us, that's probably 24.9 kV, and we have to make that determination. You know, we're talking phase to phase, we're talking phase to ground. Like I said, amps, kW, kVAR, power factor, and so on are very important. We have to understand grounding, both earth grounding, system grounding. Are we going to facilitate the flow of ground fault current? What type of protection are we going to need to coordinate with the existing infrastructure that the customer may have? And so those are just some of the things that we look at.
Makes sense. It sounds to me like if a utility wants to mitigate its risk, to have a meeting with you folks to just take care of all of that stuff in advance, to say that, hey, if we ever need, if and when, and because usually it's when, we need a utility in a box solution, everything has been pre-planned and lined up. So that makes huge sense. And speaking of, so another question came in. So how does Aggreko partner with utilities to respond to outages? What is the process that you go through? I know I know that once you get engaged, you go through your cycle, but how do you get initially interact with a customer? How does that happen? Are they calling you? Are you calling them?
Yeah, both. I mean, sometimes we meet through events through the Canadian Electric Association, so
Right.
or
Yeah.
EEI. We're also partners with them as well, and so typically, once they understand, we try to sit down with them and understand where their real big challenges are, and to see if we can affect change. And sometimes it's a 15-minute coffee, and there's nothing we can do yet, right? And when there's nothing we can do, other times it's a 15-minute coffee that leads to another meeting that leads to another meeting. Some of our best customers that we've been dealing with are extremely well. They think about their system, and they're really trying to improve year over year, right? And so we do some analytics in the background. We try to understand, well, what company maybe needs to help with their Sadie or Sapies. We do that type of thing and try to connect with those people and see if we can help, right? Because sometimes the answer is no, we just can't help, right? To your point earlier, an emergent event, if the distribution system's torn down, we might be able to run a community hall, but we can't run the system, right? But we just do it. Yeah.
Yeah,
so
I understand.
We just take the time to listen and understand if we can. We would just like to see if we can help.
Yeah, thank you. And talking about helping, I know before we came on board, Aaron and David were talking about you're kind of working around the clock right now. Aaron, could you just give it a very high level view of the type of work you're doing right now down in the States? Just a very kind of like elevator pitch. What are you doing right now to help out your customer?
So if we want to talk about Hurricane Laura, we've got diesel generators, we've got gas generators on many different sites. If you're looking at the top photo, the top left photo in this particular substation, actually our generators are not in the substation. We had to create a new fence, and the property owner just to the south of the generator location right there was gracious enough to give us about 50 feet of his yard for us to set those machines in. And I guess as a consequence of him giving up a little bit of land, he now has lights and a refrigerator and a TV now, so I'm sure he's very happy. But we've got probably, I'd say 20 to 25 of these 1.3 megawatt natural gas engine generator sets in various locations throughout Louisiana related to Hurricane Laura. And we're running at all sorts of different voltages: 240 delta with a high leg, 208 3-phase, 480 volt 3-phase, 12470, 4160, maybe even some 24.9 kV in a couple spots. So as far as the storm response, we are in general feeding our utility customers directly at low voltage, and in some cases at medium voltage, 4160 and the like. And in many cases, we are providing electricity to the distribution line or a section of the distribution line that has been satisfactorily repaired or sufficiently repaired to accept electricity, while the transmission line is being repaired. You know, the transmission line is de-energized. So yeah, that's what we're doing in Louisiana.
Wow.
As far as what we're doing all around the U.S., we've got our PSPS program in California, where we've got, I think Dave mentioned, we've got well over 100 megawatts. I think it's actually close to 150 megawatts on hire with one particular utility company in California. And all we're doing, or basically all we're doing, is we're responding to wildfires. So when a wildfire occurs and damages a distribution or damages a transmission line, we'll take our machines, and it's not necessarily plug and play like we were talking about earlier with our single trailer. But if let's say a town of 5,000 people needs 10 megawatts, it might take us a day or two just to arrive on site, and then several more days of installation, testing, commissioning, And most often within a week, sometimes less than a week, we are energized at 21 kV or 12 kV or whatever it may be to power, you know, a town. Maybe it's a remote town in the middle of the mountains.
Wow.
So and then in other parts of the U.S. and Canada, we are energizing distribution lines while our customers take planned interruptions or planned outages of their transmission lines or planned outages of their substations, so that they can do maybe switch change outs, breaker upgrades, protective relaying upgrades. We become a temporary source. Sometimes it's just for a few days. Sometimes going down for a few days allows them to do a lot more work de-energized than they could have done energized in 2 or 3 weeks.
Mm-hmm.
That's fascinating. Thank you very much for that. I was focusing more on the disaster situation, but obviously maintenance, you guys could just kind of plug in, and it's like doing a heart transplant almost for a period of time for a utility until they can, till on a temporary basis until
it wasn't really the subject of this call, but to your point, we can synchronize our generators to the grid power, drop off the grid disconnect, become asynchronous with the grid, and then 2 or 3 days later or a week later, we can synchronize our machines and your customers back to grid power without having any kind of interruption at all, if we have the right infrastructure in place and we can plan it out accordingly.
Well,
and
that's
we'll be
fantastic.
doing that webinar with CEA next month on that, actually, right? And so
fantastic, and that will be absolutely another upcoming discussion. Thank you for that, David. Well, we're approaching the top of the hour, and boy, a fascinating topic. David, thank you. Waj, Aaron, much appreciate your the explanation of what you're doing, and certainly from what I'm taking away from this is the opportunity to pre-plan for both the potential and inevitable disaster event, but also just for regular planning for your regular work. To have an opportunity to have a unit come in and do a plug and play to help stopgap you through to future success. So with that, I would like to thank each of you for joining us today, and we can invite you now to go off camera if you'd like, and we'll close up the webinar at this point.
Thank you.
Thank you very much.
thank you.
Thank you, David.
So you're welcome. So with that, we'll just talk about our next CEA Conversation Series webinars will be held on September the 29th. IBM will be presenting resilient contact centers in the time of COVID-19. And then on October the 6th, Siemens Canada will be presenting Utility Distributed Energy Resources, or DER, adoption within the energy system platform. And as Aggreko mentioned, they'll be back in the near future as well, talking more about the great stuff they do. All of CEA's future events and webinars can be found on our monthly newsletter, Current Affairs. And you can also go to news and events on the CEA's website. So get signed up for Current Affairs. It's a newsletter that goes out to 6,000 people across the industry. And you can get on that for free just by going into electricity.ca and just tapping in your email address. And the other events, as I mentioned, on the website as well, electricity.ca. So with that, thank you for joining us today, and we'll talk to you next time. Bye for now.